The methods that you are learning in this course can be applied in a variety of settings. Let's see if we can use A/B testing to examine a question that was of profound interest to the football world a couple of years ago. In 2015, the Patriots and the Colts played the AFC Championship football game. And during the game, the Colts intercepted one of the Patriots' footballs. That is, they caught a ball belonging to the other team. And they thought that that ball was a little softer than it ought to be. Footballs are supposed to be inflated to a certain degree of pressure within limits that are stipulated by the league. And it could be that a ball that is not quite inflated enough might be a little easier for a team to catch. It might give the team some advantage to be outside of the allowed limits. And so the Colts went to the match referees and said, this ball has too low of a pressure. And then all the footballs were measured, and the scandal that arose filled the airwaves. It was called Deflategate, and it was on every newscast and went on for quite some time. If you look up the Wikipedia entry for Deflategate, you will see that the scandal is commonly known as Deflategate or Ballghazi. Clearly, people are having a great time discussing this issue. And here we are, 1 year later in 2016, Deflategate returns. And Tom Brady, the quarterback, there was a question about why his cell phone had been destroyed and why the balls had appeared in a bag and had spent a little too long in some part of the stadium, and so on and so forth. All kinds of accusations being hurled back and forth. And in the end, there was a question about data. And the National Football League appointed an independent commission to look into the data. And so that's what we're going to do. We're going to take the data and we're going to see what we make of it. We'll read the data into a table called football, and then I will describe what it consists of. There were 15 balls that were measured, and each row of this table corresponds to one of the balls. Each team starts out with a dozen footballs. The first 11 of this table are the 11 Patriots balls. The one that was intercepted by the Colts was not measured. At halftime, the pressure was measured by each of two officials, Blakeman and Prillo. Pressure is measured in a standard unit of pressure called pounds per square inch. Higher means more pressure. So 11 Patriots balls were measured. The intercepted ball was not measured. 4 Colts balls were measured. What about the other Colts balls? Well, they just couldn't get to it. The measurements were happening during the halftime break. And, well, the break was over, so the game had to be played, and so all the balls went out into the field. The data consists of these 2 measurements on each of 15 footballs. And we have to decide, based on these data, whether it looks like the Patriots' balls were, well, softer than they ought to have been. And so now the first thing we notice is that these 2 officials don't always have the same measurement. That's quite common. When the same object is being measured twice, the measurements come out different. So why don't we create a new table called football. And we are going to drop the 2 measurements and replace them by one combined one. Give myself some room here. And we will just simply average the 2 measurements for each football. So we'll take we'll add the 2 arrays. of data from the two columns, and then we will divide by 2. And let's take a look at what football looks like now. So what we have is a single measurement for each football, and why don't we look at all 15. And a glance at this shows that the Patriots footballs were at a lower pressure than the Colts footballs. And so what is there to talk about? Well, this representation is unfair because at the start of the game, the two teams' footballs had started out at different pressures. Both were allowed by the league rules. The Patriots started out at 12.5 and the Colts started out at 13. It was legitimate, both of them. During the game, the pressure drops naturally. So they're not at the levels at which they started out, but it's not surprising that the Patriots' numbers are smaller than the Colts' numbers because they just started out lower. So the right thing to measure is not the pressure itself, but the drop from the starting value. So we need to figure out what the starting values were. The starting values were for each of these 11 balls 12.5, and for these 4 balls they were 13. So it would be nice to make one array consisting of 11 12.5s and then 4 13s. How do we do that? We remind ourselves that there is a very useful function called np.ones, which, if you give it a whole number argument, simply produces an array of that many ones. This is handy because we can now produce an array of 11 12.5s. And to that we can append an array of 4 13s. And this array we will call start because it consists of the starting values. Let's take a look at it. 11 12.5s, that's the starting point of the Patriots footballs, and 4 13s. And so the drop in pressure then is the starting values minus the pressure measurement that we are using, the average of the two officials' measurements, and we'll take a look at drops, and so we get an array of 15 drops. Let's create yet a new table called football, which is the team column of football. And the column of drops. What we have done is a very common aspect of data science. That is, you have a question and you have some data. You do have to do some work to get your data to a form in which you can use the values to answer your question. So now we have a variable, that is the drop in pressure, that is a fair comparison between the two teams. And even that, it looks as though most of the Patriots' drops are larger than the Colts. And to quantify that more succinctly, we could simply look at the two group averages. On average, the Colts footballs dropped by about half PSI and the Patriots by 1.2. That's quite a bit larger. Done? Well, not quite. The Patriots could claim that this could happen just by chance. Now, how does chance come into the picture? There are 15 footballs, so there are 15 values of the drops. If you just picked 11 of them at random and looked at the average of that random set compared to the remaining 4, could the difference between those two groups look like this? If so, then this difference could be due to chance. And if not, then perhaps the Patriots' amounts of drops are a little too large to be explained by chance. You can see that we're setting ourselves up to do a test of hypotheses. We're going to test whether the Colts footballs just look like a random sample of 4 out of the 15 balls, and the Patriots the remaining random sample of 11 out of 15. And we're going to compare the average drops. And so if we look at the drops themselves as a column, the observed difference between the means, and I'm doing Colts minus Patriots, so the difference is negative, the Colts had a smaller drop, was minus 0.73. Could this have happened due to chance? That's the question we're going to answer.